At this point, it should come as no surprise to learn that when we want to scale something horizontally by some factor, we multiply its x-coordinate by whatever that factor is. So in our example, h is the result of scaling f horizontally by a factor of 3. So we took each x-coordinate and tripled it to get the graph of h. K is the result of scaling f horizontally by a factor of 1/2. So we took each x-coordinate and cut it in half to get the graph of k. Again, we want to come up with expressions for h and k in terms of f. And we're going to go about this the same way we have been, by looking at the key points. So on the graph of f, we have a point -2, -2. So f of -2 is -2. We have a point 2, 4. So f of 2 is 4. We have a point 4, 1. So f of 4 is 1. To get the graph of h, we take each of those points and triple its x-coordinate. So the point -2, -2 becomes the point -6, -2. The point 2, 4 becomes the point 6, 4. The point 4, 1 becomes the point 12, 1. So we see that the output stayed the same, and the inputs are 3 times as big. What does that mean for the expression for h? When we wanted to take h of 12, we took f of 4. When we wanted to take h of 6, we took f of 2. In order to get the input of f, we needed to take not 3 times the input of h, but 1/3 of the input of h. We're dividing by 3, which is multiplying by 1/3. H of x is f of not 3 times x, but 1/3 times x. Again, what's happening here is we have to go from the input of h back to the input of f. Let's see if the same thing happens with the small scale factor. To get k, we're scaling by a factor of 1/2. We want to multiply each x-coordinate by 1/2, which is the same as dividing by 2. So the point -2, -2 on the graph of f, divide the x-coordinate by 2 and we get the point -1, -2 on the graph of k. The point 2, 4 on the graph of f, divide the x-coordinate by 2 and we get the point 1, 4 on the graph of k. The point 4, 1 on the graph of f, divide the x-coordinate by 2 and we get the point 2, 1 on the graph of k. Again, our outputs were the same, and our inputs are 1/2 as big. When we wanted to take k of 2, we took f of 4. When we wanted to take k of 1, we took f of 2. So k of x is not f of 1/2 of x, it's f of twice x. Why? Again, we have to go back from the input of k to the input of f. So k of x is f of not 1/2 x, but 2x. Again, This is an opposite. Now we're not taking the opposite with regard to sign, which we did when we were doing addition. We're taking the reciprocal now that we're doing multiplication. If g is what we get when we multiply by 1 over c before we do f, then g is what we get if we scale f horizontally, not by 1 over c, but by c. If g is what we get when we multiply by c before we do f, then g is the result of scaling f horizontally by 1 over c. The scale factor is the reciprocal of the number that we're multiplying x by. So when we were doing addition, we took the opposite with regard to addition. When we're doing multiplication, we take the opposite with regard to multiplication. Additive inverse for addition, multiplicative inverse for multiplication. That's what's going on here. We need to go back to the input of f. So we're doing the opposite of whatever operation is happening to the x coordinate.